IEEE standards. In this video, we are going to see about IEEE standards. IEEE 802.11a. IEEE 802.11 introduced as a way to provide Internet access to mobile devices using AP in the 5 GHz industrial, scientific and medical, that is ISM band, was quickly implemented throughout a wide region. Under IEEE 802.11 standards, networks occasionally receive interface from devices such as cordless phones and microwave ovens. IEEE 802.11 aims to provide wireless network connections for fixed, portable and mobile stations within tens to hundreds of meters with one medium access control, that is MAC, and several physical layer, that is PHY specifications. This version was later called 802.11a. Many subsequent enhancements were made by introducing numerous different variants and are summarized in the below table. Versions 802.11c, D, F, H and I are not included in the table as their use is limited to specific purposes. For example, 802.11c has been specifically designed for bridges, while 802.11d is primarily employed as a word made in Europe. Version 802.11d takes care of quality of service, while 802.11f meant for inter-access protocol. Version 802.11h is meant for a dynamic frequency selection, while 802.11i is specified for authentication and security. In this series, 802.11b was the first one and was commercialized as Wi-Fi AP in 1999. Later, 802.11g, 802.11n and 802.11ac have also been introduced, differing most significantly in their specification of the PHY layer. With so many variants, people started calling all of them Wi-Fi devices. As compared to other IEEE 802.11 standards such as IEEE 802.11b by G, 802.11a has less interference since the 2.4 GHz band is heavily used. However, its penetration is also reduced due to its higher carrier frequency, so the signals are absorbed readily by solid objects along its propagation path. The modulation of IEEE 802.11a uses orthogonal frequency division multiplexing, that is OFDM, with 52 subcarriers spanning over a 20 MHz spectrum. The attribution of OFDM technology provides fundamental advantages in utilizing multi-path transmission, which is common for an indoor environment. Each subcarrier can be modulated with BPSK, QPSK, 16QAM, depending on the wireless environment. IEEE 802.11b. In August 1999, a group of industry leaders formed a non-profit organization called the Wireless Ethernet Compatibility Alliance, that is WECA, to promote the IEEE 802.11 high-rate standard, that is, which eventually became IEEE 802.11b as a commercial standard to ensure the interoperability of different vendors' products. WECA selected an independent test lab to test and certify the interoperability of the IEEE 802.11b products. IEEE 802.11b operates on 2.4 GHz band with throughput of up to 11 Mbps, that is 12.8, and is functionally comparable to an Ethernet. IEEE 802.11b uses a direct extension of direct sequence spread spectrum DSSS on PHY layer. DSSS uses a continuous string of pseudonoise, that is PN code symbols, to module information, which allows multiple transmitters to share the same channel with orthogonal PN codes. This also provides wired equivalent privacy and Wi-Fi protected access. As the coverage is larger, 802.11b requires fewer access points than 802.11a for a given area. WECA was later renamed as the Wi-Fi Alliance and certifies all the IEEE 802.11 high-rate standards, that is, which include the IEEE 802.11b, IEEE 802.11a, and IEEE 802.11g products. Almost all companies selling the IEEE 802.11 equipment are members of the Wi-Fi Alliance. IEEE 802.11g, IEEE 802.11g, released in 2003, is the third modulation standard for WLAN. It operates on 2.4 G like IEEE 802.11b. The PHY layer can use either DSSS or OFDM. Due to its heritage of PHY technology from IEEE 802.11a, IEEE 802.11g can achieve higher throughput of up to 54 Mbps. Although 14 channels are available in the 2.4 GHz band, only 11 can be used in the United States due to FCC regulations. IEEE 802.11n. IEEE 802.11n is a recent amendment that incorporates multiple input, multiple output, that is MIMO technology, so that separate paths can be used for concurrent transmission and reception. IEEE 802.11n can operate on either 2.4 GHz or 5 GHz and uses either DSSS or OFDM for PHY layer modulation. Adopting multiple transmit antennas allows an AP to focus transmissions in the direction of the client, thereby increasing downlink signal to noise ratio and the data rate over a larger range. It is also possible using a process called spatial diversity to take advantage of multipath by sending multiple radio signals at the same time. The bandwidth in IEEE 802.11n can be 40 MHz, and the maximum PHY layer data rate is raised from 54 Mbps to 600 Mbps. MIMO improves communicate performance with the use of multiple antennas at both the transmitter and receiver and can handle multiple transmitted data streams. Significant increase in downlink signal to noise ratio. Data throughput and link range can be observed by focusing transmissions in the direction of the client and is feasible without the additional cost of bandwidth or transmission power by taking advantage of antenna diversity and spatial multiplexing. IEEE 802.11 AC. The next step in the IEEE 802.11 development results in IEEE 802.11 AC. The aim of this standard is basically to replace IEEE 802.11n. The goal of IEEE 802.11 AC is to offer data rates of at least 1 gigabits per second in multi-station environment and at least 500 megabits per second for a single station. IEEE 802.11 AC is a wireless computer networking standard based on 802.11. IEEE 802.11 AC functions at WLAN 5 GHz band. In order to achieve planned performance values for the data rate, IEEE 802.11 AC extends the air interface functionality of 802.11n by providing frequency bandwidth up to 160 MHz. IEEE 802.11 AC standards define a mandatory 80 MHz channel bandwidth for stations, that is STAs, whereas IEEE 802.11n provides a maximum of 40 MHz. Furthermore, IEEE 802.11 AC has an optional 160 MHz bandwidth available. IEEE 802.11 AC also gives possibility to apply maximum of 8x8 MIMO antennas, whereas IEEE 802.11n defines a maximum of 4x4 MIMO. Multi-user MIMO, that is MU-MIMO, can also be utilized in IEEE 802.11 AC. IEEE 802.16, that is WiMAX. In this video, we are going to see about IEEE 802.16, that is WiMAX. WiMAX, that is Worldwide Interoperability for Microwave Access, that is IEEE 802.16, is a wireless communication standard defined by IEEE. It provides data rates of about 30 to 40 megabits per second. The enhancements published in 2011 have increased the maximum theoretical data rate up to 1 gigabytes per second for fixed stations, which complies with the 4G requirements of ITU-R. The term WiMAX is a result of the work of the WiMAX Forum. The forum was initiated in 2001 in order to promote conformity and interoperability of the standard. According to the WiMAX Forum, WiMAX is a standards-based technology that enables the delivery of last-mile wireless broadband access as an alternative to cable and DSL. The IEEE 802.16e 2005 added Scalable Orthogonal Frequency Division Multiple Access, that is SOFDMA, to the previous definition of IEEE 802.16 2004 AIR interface standard, which, together with other features for support of mobility, created the basis for WiMAX System Release 1. Further enhancements were added via IEEE 802.1.6e 2009. The first WiMAX system release 1 deployments took place in 2006. According to WiMAX Forum, WiMAX service providers has covered more than 600 million people with over 500 deployments in over 140 telecommunications markets worldwide. The AIR interface enhancements approved for WiMAX, designated as WiMAX AIR Interface Release 1.5, that is AIR Interface R1.5, were ready for certification testing in 2010, and the advanced version, Release 2.0, is already compliant with the ITUR performance requirements of 4G. The basic idea of IEEE 802.16 is to offer a wide area WLL, that is wireless local loop, which is defined to function within 10 to 66 GHz frequency band. The maximum data rate of the basic version of 802.16 is 120 megabits per second. The actual WiMAX is defined in IEEE 802.16 2004, or more officially 802.16 REBD, and it is designed for fixed usage. The enhanced version of WiMAX, called Mobile WiMAX, is defined in IEEE 802.16e, that is IEEE 802.16 2005, and it also includes methods for mobility management. It supports portable and mobile communication methods. The WiMAX frequency range is in 2 to 11 GHz. The maximum data rate of WiMAX is 70 megabits per second. The portable communication category means in practice an extension of the fixed communication in such a way that the connection can be established from various access points. Nevertheless, the portable category does not support seamless handover between access points. This possibility of changing access points for communications is called nomadic access method. It requires initiation of the connection separately via each access point. The mobile communications category in the WiMAX environment means that the communications channel can be changed relatively quickly so that the amount of lost packets is minimal during the procedure. The mobile category WiMAX thus practically supports real-time VoIP calls in a mobile environments. The standardization of IEEE 802.16 has been divided into various subgroups, just as is the case with 802.11. 802.16 Maintenance Task Group takes care of the functioning of the service definitions and corrects upon need the definitions. (802.16e) takes care of mobility management. It concentrates on the enhancements of MAC layer, including procedures for channel change and calls, as well as the scalability aspects of OFDMA, that is orthogonal frequency division multiplex access. 802.16f takes care of information management of fixed services, whereas 802.16g handles management procedures and services, and 802.16h handles permissions. In general, WiMAX defines interoperable implementations of the IEEE 802.16 family of wireless network standards ratified by the WiMAX Forum. It should also be noted that Bluetooth and UWB, that is ultra-wide band defined by IEEE 802.15, can act as wireless networks, although the first Bluetooth deployments and definitions have been based on pairing the communications part between two devices, like mobile phone and Bluetooth headset. The IEEE 802 series has addition from 2004, 802.22, which extends the functional areas of the previously defined systems. It is meant especially for the rural and very wide areas with low population density. It is a broadcast technology which would be suitable for TV broadcast type of contents. The term for 802.22 is thus cognitive radio. WiMAX standardization. WiMAX can be classified to FWA, that is fixed wireless access, especially in the initial phase of the deployments. Both ETSI and IEEE have been active in the specification work on the system. The WiMAX definitions have been taken care of by IEEE and WiMAX Forum. The latter has a separate subgroups, Designing Regulations, that is RWG, Regulatory Working Group. This group has a goal to facilitate the functioning of WiMAX solutions in such a way that they are not interfering with other existing systems. The special task of the group is to take care of planned frequency band allocated for WiMAX equipment and to identify additional frequency bands. Independent networks. In this video, we are going to see about independent networks. On the left is an independent BSS, that is IBSS. Stations in an IBSS communicate directly with each other and thus must be within direct communication range. The smallest possible 802.11 network is an IBSS with 2 stations. Typically, IBSS are compared to a small number of stations set up for a specific purpose and for a short period of time. One common use is to create a short-lived network to support a single meeting in a conference room. As the meeting begins, the participants create an IBSS to share data. When the meeting ends, the IBSS is dissolved. Due to their short duration, small size and focused purpose, IBSs are sometimes referred to as ad hoc BSSs or ad hoc networks. Radio frequency channel. The IBSS configuration requires the user to set the specific RF channel that will be used by all devices that are part of the same IBSS network. This is accomplished in the client utility software for the network adapter. Some client software utilities set the automatically, in which case the IBSs will use the channel automatically specified. It is important to understand that all devices in any common IBSs must be communicating on the same channel. IBSS security. With the IBSS network, there is no centralized control and no security management features. Security is left up to the individual user or device. If a user inadvertently shares a resource, it could expose sensitive information and pose security threats. This can be a concern for many enterprise installations, and therefore the use of an IBSS may be against corporate policy. IBSS terms. The wireless LAN industry uses several different terms to identify an IBSS. An IBSS is usually identified by one of the three terms: IBSS, ad hoc, peer-to-peer. Regardless of the terminology used, IBSS, hoc, or peer-to-peer, it comes down to wireless LAN devices connecting to each other without the use of an access point or other wireless infrastructure device. All devices in an IBSS network work, that is, independently of one another, and there is no centralized management or administrative capacity. This type of connection may be used in homes or small offices for ease of installation. Advantages and disadvantages of IBSS. The advantages and disadvantages of an IBSS network will vary depending upon the application. Some of the advantages of IBSS are as follows: easy of configure, no investment in access point hardware. Some disadvantages of IBSS are as follows: limited ratio frequency range, no centralized administration capability, not scalable, difficult to secure. Basic Service Set, that is BSS. In this video we are going to see about Basic Service Set, that is BSS. Basic Service Set, that is BSS. The Basic Service Set, that is BSS, is the foundation of the wireless network. This mode consists of an access point connected to a network infrastructure and associated devices. This is considered the foundation because it may be one of the many access points that form a wireless network. When a BSS is set up, each access point is connected to a network infrastructure, also known as the distribution system, that is DS, and allows connected wireless, that is LAN devices to access network resources based on the appropriate permissions to the device or user has access to. The radio frequency area of coverage depends on several factors such as the antenna gain and output power settings. This area of coverage is known as the Basic Service Area, that is BSA. Any wireless device in radio range and part of the BSA, including SSID and security settings, will be able to successfully connect to the access point. As mentioned earlier, an infrastructure mode consists of an access point connected to a distribution system. The BSS consisting of one access point is a common implementation in many homes, small office or home office, SOHO or small to medium. The decision to use a single access point will depend on several factors, some of which are size of the location, use of the location, use of wireless network, and how many devices will be connected. Just as in IBSS configuration, there are several parameters that need to be configured for a BSS. These parameters include SSID or the name of the network and the radio frequency channel to be used. The access point will broadcast these and other parameters about the network to devices wanting to connect to the BSS, therefore requiring advantages and disadvantages of BSS. A BSS has many benefits, advantages and disadvantages. Some of the advantages are as follows. Uses intelligent devices with a large feature set to provide users with consistent, reliable and secure communications to a wireless network. Useful in a variety of situations, homes, SOHO, and small to large business. Very scalable, you can increase the coverage and capacity of a BSS by adding more access points. Centralized administration and control. Security parameter and specific access can be set centrally. ESS Network Fundamentals and Deployment. In this video, we are going to see about ESS Network Fundamentals and Deployment. BSS can create coverage in small offices and homes, but they cannot provide network coverage to larger areas. 802.11 allows wireless network of arbitrarily large size to be created by linking BSS in an extended service set, that is ESS. An ESS is created by changing BSS together with a backbone network. All the access points in an ESS are given the same service set identifier, that is SSID, which serves as a network name for the users. 802.11 does not specify a particular backbone technology. It requires only that the backbone provides a specified set of services. The ESS is the union of the four BSS, that is, provided that all the access points are configured to be part of the same, that is ESS. In real-world deployments, the degree of overlap between the BSS would probably be much greater than the overlap. Stations within the same ESS may communicate with each other, even though these stations may be in different basic service areas and may even be moving between basic service areas. For stations in an ESS to communicate with each other, the wireless medium must act like a single layer 2 connections. Access points as a bridges, so direct communicate between stations in an ESS requires that the backbone network also look like a layer 2 connection. First generation access points required direct layer 2 connections through hubs or virtual LANs. Never producers implement a variety of tunneling technologies to emulate the layer 2 environment. Extended service areas are the highest level abstraction supported by 802.11 networks. Access points in an ESS operate in concert to allow the outside world to use the situation's MAC address to talk to a station no matter what its location is within the ESS. In figure, the routes uses the station's MAC address as the destination to deliver frames to a mobile station. Only the access point with which that mobile station is associated delivers the frame. The router remains ignorant of the location of the mobile station and relies on the access points to deliver the frame. Key characteristics of 802.11 wireless LANs. In this video, we are going to see about key characteristics of 802.11 wireless LANs. Now that we have looked at the fundamental building blocks, we can make some general observations regarding the capabilities and limitations of wireless LANs. There are a few important characteristics shared by all of the 802.11 wireless LANs that distinguish them from typical wired implementations. Those characteristics have an impact on their ability to carry voice calls and on the number of simultaneous calls they will be able to support. Half duplex. There is only one radio channel available in each wireless LAN, so only one device, the access point or a client station, can be sent at a time. Shared media, where each wired user is typically connected to his or her own port on the LAN switch. A number of WLAN clients will typically associate with a single access point and share one radio channel. All stations associated with that access point will wire for access to the channel, so the time required to access the channel will be a random function. For voice services, that channel contention will affect transit delay and jitter. Capacity or range relationship. The maximum capacity of the WLAN is based on which radio link interface is used, that is 802.11a, b, g, n. However, not all stations will be able to operate at the defined maximum data rate, and each radio link interface defines a number of fallback rates. The data rate for each device is based on its distance from the access point, impairments in the radio path, and the level of interference on the radio channel. Lower transmission capacity reduces the number of simultaneous calls an access point can handle. Different transmission rates, same channel. In a wireless LAN, different users can operate at different bit rates on the same shared channel. The lower bit rate users affect the performance of higher bit rate users, as the low bit rate users will keep the channel busy longer as they send a message. Transmission acknowledgements. As WLAN stations cannot hear while they are sending, the recipient must return an acknowledgement for every correctly. Protocol overhead. While the transmission rate over the wireless channel may be 11 or 54 Mbps, the requirement to send acknowledgements and other overhead features in the protocol reduce the throughput to about 50% of that rate. Typical range of 802.11a or B or G, N or ACW LAN. In this video, we are going to see about typical range of 802.11a or B or G or N or ACW LAN. Typical range of 802.11a or B or G, N or ACW LAN. Various 802.11 standards have evolved over the years. Standards include IEEE 802.11a. Operates at the 5 GHz frequency band and offers speed of up to 54 megabytes per second. Because this standard operates at higher frequencies, it has a smaller coverage area and is less effective at penetrating building structures. Devices operating under this standard are not interoperable with the 802.11b and 802.11g standards that are described as follows. IEEE 802.11b operates in the 2.4 GHz frequency band and offers speeds of up to 11 Mbps. Devices implementing this standard have a longer range and are better able to penetrate building structures than devices based on 802.11a. IEEE 802.11g operates in the 2.4 GHz frequency band and offers speeds of up to 54 Mbps. Devices implementing this standard therefore operate at the same radio frequency and range as 802.11b but with the bandwidth of 802.11a. IEEE 802.11n operates in the 2.4 or 5 GHz frequency bands. The typical expected data rates are 100 Mbps to 600 Mbps with a distance range of up to 70 meters. It is backward compatible with 802.11a or B or G devices. IEEE 802.11ac can simultaneously operate in the 2.4 and 5 GHz frequency bands, providing data rates up to 450 megabytes per second and 1.3 gigabytes per second, that is 1300 Mbps. It is backward compatible with 802.11a or B or G or N devices. Access point. In this video, we are going to see about access point. In a wireless local area network, that is WLAN, an access point is a station that transmits and receives data, that is sometimes referred to as a transceiver. An access point connects users to other users within the network and also can serve as the point of interconnection between the WLAN and a fixed wire network. Each access point can serve multiple users within a defined network area. As people move beyond the range of one access point, they are automatically handed over to the next one. A small WLAN may only require a single access point. The number required increases as a function of the number of network users and the physical size of the network. When an access point is used by itself without a connection to a wired LAN, the device functions as a basic repeater. The access point periodically broadcasts a beacon frame which informs all stations within receiving distance of the presence of the AP and its capabilities. Client stations then communicate with the access point in order to reach other stations, with the AP in effect relaying data between stations. The area of coverage of the BSS is referred to as the Basis Service Area, that is BSA. Because communications occur through the access point, another name for the BSS is an infrastructure BSS. However, to avoid confusion with an independent BSS, we will not abbreviate the former. The right portion of Exhibit 23 illustrates a BSS in which an access point provides a connection to a wired LAN. In doing so, the access point functions as a wireless to wired LAN bridge. Similar to a conventional bridge, the access point works on the 3 FS rules: filtering, forwarding, and flooding frames. The access point constructs a port address table. However, instead of multiple wired ports, the access point typically works with one wired port, with the wireless over-the-air transmission representing a second port. Initially, the port address table is empty when the access point is powered on. As the frame reaches the access point, the AP notes its source address and enters that address in its port address table. Because the destination address is not initially known, the access point floods the frame, sending it onto the wired port as well as over the air. Let's now assume that the first frame was directed to a server on the wired LAN and the server responds, transmitting a frame with the destination address being the source address of a wireless station. The frame flows to the access point, which examines its port address table and notes that the destination is on the air. Bridging. In this video, we are going to see about bridging. Network bridging is the action taken by network equipment to create an aggregate network from either 2 or more communication networks or 2 or more network segments. If one or more segments of the bridged network are wireless, it is known as wireless bridging. Bridging is distinct from routing, which allows multiple different networks to communicate independently while remaining separate. A network bridge is networking hardware that connects multiple network segments. In the OSI model, bridging is performed in the first 2 layers below the network layer, that is layer 3. Network segments that have an identical or very similar structure on the data link layer, that is layer 2, can usually be bridged together. Example, various Ethernet speed rates, that is such as fast Ethernet to gigabit Ethernet or token ring to Ethernet. This is in contrast to a simpler repeater that can only connect segments that have a nearly identical physical layer, that is layer 1. Example, 10 base T to 10 base 2 or 100 base TX to 100 base FX. The types of bridging connections are as follows. Point to point. In this mode, two bridges talk to each other and connect two segments of a network. In this mode, the bridges don't communicate with any nearby wireless clients, that is like PCs, so this mode is usually used to span across area connecting two wired networks, that is such as the home to guest home example we used earlier. You can still connect another access point to the wired location in a remote location if you need wireless connectivity there. Point to multipoint. In this mode, several wireless bridges talk to each other, that is, one bridge is boss controlling all the communications. Like point-to-point mode. In this type of connection, the bridges are used only for the inter-bridge communications and won't talk to nearby wireless clients. This kind of network bridging mode isn't very common in home or small office networks. Wireless repeater. In this mode, a remote wireless bridge connects back to the other segment of the network and also talks to local wireless clients. This is a very common bridging scenario found in home networks. The big advantage of using a repeater is economic. You have to buy less wireless gear. The disadvantage is performance because you are effectively sending data twice over the same airwaves and frequencies, that is once from the original base station or bridge and again from the repeater. Your data throughout is reduced in half. Wireless router AWLAN architecture. In this video, we are going to see about wireless router AWLAN architecture. In an 802.11 WLAN, all the components belonging to the WLAN are referred to as stations. A set of stations can form a basis building block called Basic Service Set, that is BSS. The stations in the basic service set communicate with each other obeying the same networking protocol under the same shared wireless medium, which may generate medium access collisions. Every BSS has a unique identification, that is ID, called BSS ID, which is the MAC address of the access point servicing the BSS. Multiple BSS connected through a wired or wireless distribution system can form an extended service set, that is ESS. Each ESS also has an ID called Service Set Identifier, that is SSID, which can be up to 256 characters long now. From the viewpoint of the network architecture, WLANs can be divided into two categories: infrastructure-based WLANs and ad hoc WLANs. The majority of current WLANs is an infrastructure based, such as IEEE 802.11 WLANs. In an infrastructure-based WLAN, each device connects to the network by establishing a wireless connection to a pre-installed base station to transmit and receive packets. The base stations in the WLAN are usually connected through high-bandwidth wired connections. In this way, the communication typically takes place between the wireless clients and the base station rather than directly between the wireless clients. The main aim of the infrastructure-based networks is to provide wireless services to users in a fixed network area. An example of an infrastructure-based WLAN can be found in figure. Unlike the infrastructure-based wireless network, the stations in an ad hoc network communicate with each other directly peer-to-peer, that is P2P, without the need of any pre-existing fixed infrastructure or base stations. In this way, the ad hoc network can offer the service to users without the constraints of certain geographical situations. ScatterNet. In this video, we are going to see about ScatterNet. Multiple piconets overlapping each other's coverage area form ScatterNets. ScatterNets make it possible for Bluetooth units to participate in multiple piconets simultaneously. The time division multiplexing scheme is employed for a device participating in more than one piconet such that it is active in one piconet for certain time slots, and in the next set of time slots it listens to another piconet, and so on. In a ScatterNet topology, a single device can play different roles, that is, master or slave in different piconets, but no single device can be a master of more than one piconet simultaneously. By forming as many piconets as possible within a ScatterNet, the usage of the available spectrum is optimized. This optimization is possible since within a ScatterNet all the devices share the same frequency band. But each piconet uses different hop sequences and therefore transmits on different channels. This leads to maximum data transfer within the limited frequency band. This figure displays the formation of a ScatterNet in multiple piconet. ScatterNets can also be rearranged to give better overall performance. For example, if two slaves need to communicate among themselves, it might be wiser to create a new piconet that contains only these two nodes, while they both are still parts of their original piconets if traffic flows to or from them, or if they both need to receive control information. Since the frequency hopping spread spectrum, that is FHSS system, makes Bluetooth systems more robust against interference, formation of new piconets result in gain rather than loss. The concept of ScatterNets establishes the flexibility in creating dynamic Bluetooth networks. Four major functional requirements of a ScatterNet are as follows: establishment of ScatterNet and their maintenance, data transfer in a ScatterNet, scheduling in intra and inter-piconet, switching of master-slave roles, establishment of scatternet and their maintenance. To have an efficient infrastructure for IP networking on Bluetooth, piconets and scatternets must be able to adapt to the connectivity, traffic distribution, and node mobility in the network. This is mainly achieved by setting up new piconets or terminating others in order to attain the optimal scatternet topology. In this context, optimal scattering refers to a scatternet that, for instance, yields minimum delay or maximum throughput. But it could mean minimizing energy consumption in network nodes. To ensure ad hoc operation, the function for forming and maintaining scatternets must be distributed. Bluetooth ad hoc topology. In this video, we are going to see about Bluetooth ad hoc topology. The topology of the Bluetooth is referred to as a scattered ad hoc topology. In a scattered ad hoc environment, a number of small networks, each supporting a few terminals, coexist or possibly interoperate with one another. To implement such a network, we need a plug-and-play environment. The network should be self-configurable, providing an easy mechanism to form a new small network as well as participation in an existing small network. To implement that environment, the system should be capable of providing different states for connecting to the network. The terminals should have options to associate with multiple networks at the same time. The access method should allow formations of small independent ad hoc cells as well as the possibility of interacting with the large voice and data networks considered by Bluetooth. To accommodate these features, the Bluetooth specification defines a small cell as a piconet and identifies 4 states: master, that is M, slave, that is S, standby, that is SB, and parked or hold, that is P, for a terminal. Like other ad hoc topologies, such as the one supported by IEEE 802.11, each terminal can be an M or an S. The Bluetooth topology, however, allows S terminals to participate in more than one piconet. AM terminal in the Bluetooth can handle 7 simultaneous and up to 200 active slaves in a piconet. If access is not available, then a terminal can enter the SB mode, waiting to join the piconet later. A radio can also be in a P mode in a low power connection. In the P mode, the terminal releases its MAC address, while in the SB state, it keeps its MAC address. Up to 10 piconets can operate in one area. Bluetooth specifications have selected the unlicensed ISM bands at 2.4 GHz for operation. The advantage is the worldwide availability of the bands, and the disadvantage is the existence of other users. In particular, IEEE 802.11 and 802.11b products in the same band. Bluetooth operating range. In this video, we are going to see about Bluetooth operating range. The actual range of any wireless device depends on a wide variety of factors, that is, operating environment, antenna design, enclosure, device orientation, etc. But Bluetooth Low Energy unsurprisingly focuses on a very short range communication. Transmit power, that is typically measured in dBm, is usually configurable over a certain range, that is usually between 30 and 0 dBm. But the higher the transmit power, the better range. The more depends are placed on the battery, reducing the usable lifetime of the battery cells. It is possible to create and configure a BLE device that can reliably transmit data 30 meters or more line of sight, but a typical operating range is probably closer to 2 to 5 meters, with a conscious effort to reduce and save battery life without the transmission distance becoming a nuisance to the end user. Key characteristics of Bluetooth technology. In this video, we are going to see about key characteristics of Bluetooth technology. It is a short-range communication technology to connect to devices using short-range radio frequency, that is RF, which is intended to replace communication that uses cabling. It is used mainly to establish wireless personal area networks, that is WPAN, commonly referred to as ad hoc or peer-to-peer, that is P2P networks. This technology nowadays are integrated into many types of business and consumer devices such as mobile phones, PDA, laptops, headsets, vehicles, printers. Bluetooth is a low-cost, low-power technology which provides small wireless networks. The devices with this technology connect each other through short-range, ad hoc networks known as piconets. Every time a Bluetooth-enabled device enter or leave radio proximity, the piconets gets established automatically and dynamically. Bluetooth operates in the unlicensed 2.4 GHz to 2.4835 GHz industrial, scientific and medical, that is ISM frequency band. Many technologies such as IEEE 802.11b or G, WLAN standard operate in this band. It employs frequency hopping spread spectrum, that is FHSS, for every transmissions. Also, FHSS helps to minimize the interference and transmission errors as well as provides a limited level of transmission security. Also, the communication between the devices uses 79 different radio channels by hopping frequencies at 1 MHz interval, giving a high degree of interference immunity and allowing better transmission within the spectrum. The hopping provides greater performance even when other technologies are being used simultaneously with Bluetooth technology. Device classes of power management. In this video, we are going to see about device classes of power management. The range of Bluetooth devices is characterized by the three classes that define power management. Table summarizes the classes including their power levels in milliwatts, that is MW, and decibels reference to 1 milliwatt, that is dBm, and their operating ranges in meters, that is M. Most small battery-powered devices are Class 2, while Class 1 devices are typically USB dongles for desktop and laptop computers as well as access points and other AC-powered devices. So that Bluetooth devices can find and establish communication with each other, discoverable and connectable modes are specified. A device in discoverable mode periodically listens on an inquiry scan physical channel that is based on a specific set of frequencies and will respond to an inquiry on that channel with its device address, local clock and other characteristics needed to page and subsequently connect to it. A device in connectable mode periodically listens on its page scan physical channel and will respond to a page on that channel to initiate a network connection. Therefore, knowing a device's address and clock is important for paging and subsequently connecting to the device. Wireless communication NFC. In this video, we are going to see about wireless communication NFC. The basic service set, that is BSS, is the foundation of the wireless network. Near field communication, that is NFC, is a short-range wireless communication using RFID technology. It allows communication between NFC-enabled devices. This bidirectional method of communication has a range of around 5 to 10 cm with data rates of 1,06,212 and 424 kbps. NFC technology has a large potential for mobile services, and some of the potential applications include using the mobile phones. Emulate smart cards like credit cards, library cards, etc., allowing users to exchange their contact information or electronic money with each other. Read information from NFC tags contained in smart postures or items such as DVDs or CDs. Use mobile ticketing services, which enable the mobile phones to be used in public transportation, travel cards that are common in large parts of the world. NFC devices can be operated in peer-to-peer mode, card emulation mode, and read or write mode. Peer-to-peer mode. This mode works on the ISO or IEC 18092 standard, where data exchange happens between two NFC devices. The data exchanged may be a simple text, image, URL, etc. Card emulation mode. In this mode, the NFC device acts as an NFC tag for an external reader that is similar to contactless smart card, which enables e-ticketing and contactless payment. read or write mode. In this mode, NFC communication is achieved by two devices, one of which is an NFC reader or writer and the other is a passive NFC tag. E-ticketing deals with enabling quick ticketing at bus and train stations and also payment of toll on the highways. A similar concept may also be used for carrying out transactions at merchant establishments. A secure payment gateway is required in this class of applications. Smart posters help provide information about objects. This information may be in the form of text, images, URL, etc. Some of the typical advantages of NFC-enabled devices include: the NFC technology is compatible with existing RFID structures, existing RFID tags, and contactless smart cards. NFC technology is easy to use and familiar to people because users have no requirement to possess any prior knowledge about the technology. Emerging wireless technologies. In this video, we are going to see about emerging wireless technologies. Today, wired connections are slowly being replaced by different latest emerging wireless technologies. Emergency of new wireless technologies has helped to bring out many new ideas and applications to the society. In this era, we are all expecting different solutions in the wireless field, which helps to explore out many new types of wireless technology. Wireless technology is just a latest technical term given to describe telecommunication where the EM, that is electromagnetic waves, carries signal over communication path. Now, let's look on to the latest emerging wireless technologies. One of the most striking changes in the use of technology in the last year or so has been the explosive growth in the use of wireless networks for internet and local network access. We will be looking in this column at the varieties of wireless connectivity now in use, including infrared, cellular and Wi-Fi, that is 802.11b, as well as those just now arriving on the scene such as Bluetooth and 3G. The promise of ubiquitous wireless networks dramatically enhances the usefulness of small internet cable devices. Internet. In this video, we are going to see about Internet. Recent advantages in mobile and wireless communication and personal computer technology have created a new paradigm for information processing. Today, mobile and wireless communication exist in many forms, providing different types of services. Existing forms of mobile and wireless communications continue to experience rapid growth, and new applications and approaches are being spawned at an increasing rate. Recently, the mobile and wireless internet has become one of the most important issues in the telecommunications arena. The development of the mobile and wireless internet is the evolution of several different technologies coming together to make the internet more accessible. Technologies such as the internet, wireless network, and mobile computing have merged to form the mobile and wireless internet. The mobile and wireless internet extends traditional internet and World Wide Web services to wireless devices such as cellular phones, personal digital assistants that is PDAs, and notebooks. Mobile and wireless internet can give users access to personalized information anytime and anywhere they need it, and thus empower them to make decisions more quickly and bring them closer to friends, family, and work colleagues. Wireless data communications methods have been around for some time. However, lack of standards, robust infrastructure, and enabling technologies and prohibitive cost have limited the use of wireless networks for information exchange. However, with the advent of several new technologies and standards over the past few years, things have changed dramatically. It is now becoming clear that the internet may not be suitable for addressing the emerging needs of today's mobile and wireless internet users who desire access to multimedia services regardless of location. Projections have been made by industry analysts that by the year 2003, there will be more than 1 billion wireless subscribers, thus over 1 billion wireless communication devices in use. In recent years, there have been tremendous growth in two technological sectors, the internet and mobile and wireless communications. The combination of both developments, the growth of the internet and the success of mobile and wireless networks, suggests that the next trend will be an increasing demand for mobile and wireless access to internet applications. Email. In this video, we are going to see about email. Email, that is electronic mail, is the exchange of computer-stored messages by telecommunication. Email messages are usually encoded in ASCII text. However, you can also send non-text files such as graphic images and sound files as attachments sent in binary streams. Email was one of the first uses of the internet and is still the most popular use. A large percentage of the total traffic over the internet is email. Email can also be exchanged between online service provider users and in networks other than the internet, both public and private. One of the today's visions in mobile computing is ubiquitous information access. Information, that is, example email, fax, and web pages, should be available anywhere at any time. During the last year, the market brought up a big variety of mobile devices with differing functionality. This development results in an increasing amount of wireless subscribers and the desire to access information and services provided by the internet. Unfortunately, most of the currently available applications and services for the internet accept high bandwidth connections and well-equipped client devices. One of the most interesting applications, that is, because it addresses basic user needs, is reading and writing email. Even mobile phones allow the access to email. But currently, the download of messages via wireless networks or even via a standard modem is very unsatisfying. Email tools do not allow the selection of certain message content or the adaptation of attachments. Especially when only a slow connection is available, needless data within a message, example an audio attachment, while the device is not audio enabled, should be filtered out automatically. Furthermore, large attachments should not be downloaded or compressed before the transfer. Moreover, the user should be able to determine what messages he wants to read, example, only the messages from certain senders. These examples point out three areas of adaptation: device capabilities, network connection, and user preferences. Exceptions, example, a user needs to download a large attachment because it contains a map to a location he urgently searches for, should also be handled by the application. Global Positioning System. In this video, we are going to see about a global positioning system. The Global Positioning System, that is GPS, is a satellite-based radio navigation system provided by the United States Department of Defense. It provides unequaled accuracy and flexibility in positioning for navigation, surveying, and GIS data collections. GPS is the shortened form of Navstar GPS. This is an acronym for Navigation System with Time and Ranging Global Positioning System. One can easily locate oneself with respect to the objects that surround him and position oneself relative to them. But doing that in the middle of a desert or in the middle of an ocean where are no reference objects is a problem. For many centuries, the sun and the stars were used for navigation. On land, surveyors and explorers used familiar reference points to base their measurements or find their way. These methods worked well within certain limitations like non-visibility of the sun and the stars when it is cloudy. For two-dimensional definition of any point on the surface of Earth, we require two parameters, the latitude and longitude, that is, geographical coordinates. The three-dimensional positional values include height from a reference datum in addition to latitude and longitude. By observing celestial bodies like the sun, the moon, and the stars with the help of an astronomical theodolite or navigational sextant, one can fix a positional value on the surface of Earth. For establishing a positional value on the surface of Earth, the above method was being used for centuries. But the precise position could not be determined very accurately with the help of conventional methods. To solve these difficulties, in the beginning of 1970s, a new project was devised, the Global Positioning System, that is GPS. The concept promised to fulfill all the requirements such as finding positional values accurately at any point on the Earth's surface, at any time and in all weather conditions. General Packet Radio Service, that is GPRS. In this video, we are going to see about General Packet Radio Service, that is GPRS. General Packet Radio Services, that is GPRS, is a packet-based wireless communication service that promises data rates from 56 up to 111 kbps and continuous connection to the internet for mobile phone and computer users. The higher data rates allow users to take part in video conferences and interact with multimedia websites and similar applications using mobile handheld devices as well as notebook computers. GPRS is based on Global System for Mobile, that is GSM communication, and complements existing services such as circuit-switched cellular phone connections and the short message service, that is SMS. GPRS packet-based services cost users less than circuit-switched services since communication channels are being used on a shared use, as packets are needed basis rather than dedicated to only one user at a time. It is also easier to make applications available to mobile users because the faster data rate means that middleware currently needed to adapt applications to the slower speed of wireless systems are no longer be needed. As GPRS has become more widely available along with other 2.5G and 3G services, mobile users of virtual private networks, that is VPNs, have been able to access the private network continuously over wireless rather than through a router dial-up connection. GPRS also complements Bluetooth, a standard for replacing wired connections between devices with wireless radio connections. In addition to the Internet Protocol, that is IP, GPRS supports X.25, a packet-based protocol that is used mainly in Europe. GPRS is an evolutionary step toward Enhanced Data GSM Environment, that is EDGE, and Universal Mobile Telephone Service, that is UMTS. Enhanced Data GSM. In this video, we are going to see about Enhanced Data GSM. EDGE is an evolution to the GSM mobile cellular phone system. The name EDGE stands for Enhanced Data Rates for GSM Evolution, and it enables data to be sent over a GSM TDMA system at speeds up to 384 kbps. In some instances, GSM Edge Revolution systems may also be known as EGPRS or Enhanced General Packet Radio Service Systems. Although strictly speaking a 2.5G system, the GSM Edge cellular technology is capable of providing data rates that are a distinct increase on those that could be supported by GPRS. Edge Revolution is intended to build on the enhancements provided by the addition of GPRS, that is, General Packet Radio Service, where packet switching is applied to a network. GSM Edge cellular technology is an upgrade to the existing GSM or GPRS networks and can often be implemented as a software upgrade to existing GSM or GPRS networks. The GSM Edge technology requires a number of new elements to be added to the system. Use of 8PSK modulation. In order to achieve the higher data rates within GSM Edge, the modulation format can be changed from GMSK to 8PSK. This provides a significant advantage in being able to convey 3 bits per symbol, thereby increasing the maximum data rate. Base station. Apart from the upgrade to incorporate the 8PSK modulation capability, other small changes are required to the base station. These are normally relatively small and can often be accomplished by software upgrades. Upgrade to network architecture. GSM Edge provides a capability for IP-based data transfer. As a result, additional network elements are required. These are the same as those needed for GPRS and later for UMTS. In this way, the introduction of Edge technology is part of the overall migration path from GSM to UMTS. The two main additional nodes required for the network are the Gateway GPRS Service Node, that is GGSN, and the Service GPRS Service Node, that is SGSN. The GGSN connects to packet-switched networks such as the Internet and other GPRS networks. The SGSN provides a packet-switched link to mobile stations. Mobile stations. It is necessary to have a GSM Edge handset that is Edge compatible, as it is not possible to upgrade handsets. This means that the user needs to buy a new GSM Edge handset. Environment, that is Edge. In this video, we are going to see about environment, that is Edge. Edge. The Enhanced Data GSM Environment is a faster version, the global system for mobile, that is GSM wireless service, designed to deliver data at rates up to 384 kbps and enable the delivery of multimedia and other broadband applications to mobile phone and computer users. The Edge standard is built on the existing GSM standard using the same time division multiple access, that is TDMA, frame structure and existing cell arrangements. Ericsson notes that its base stations can be updated with software. Edge became commercially available in 2001. It is regarded as an evolutionary standard on the way to the Universal Mobile Telecommunications Service, that is UMTS. Universal Mobile Telecommunications Service, that is UMTS. In this video, we are going to see about Universal Mobile Telecommunications Service, that is UMTS. UMTS, that is Universal Mobile Telecommunications System, is so-called third generation, that is 3G broadband, packet-based transmission of text, digitized voice, video and multimedia at data rates up to and possible higher than 2 megabits per second, that is Mbps, offering a consistent set of services to mobile computer and phone users no matter where they are located in the world. based on the Global System for Mobile, that is GSM Communication Standard UMTS, endorsed by major standards bodies and manufacturers, is a planned standard for mobile users around the world by 2002. Once UMTS is fully implemented, computer and phone users can be constantly attached to the internet as they travel, and as they have roaming service, have the same set of capabilities no matter where they travel to. Users will have access through a combination of terrestrial wireless and satellite transmissions. Until UMTS is fully implemented, users can have multi-mode device that switch to the currently available technology, such as GSM 900 and 1800, where UMTS is not yet available. Today's cellular telephone systems are mainly circuit switched, with connections available dependent on circuit availability. Today's cellular telephone systems are mainly circuit switched, with connections available dependent on circuit availability. Packet switched connection using the Internet Protocol, that is IP, means that a virtual connection is always available to any other endpoint in the network. It will also make it possible to provide new services such as alternative billing methods, pay-per-bit, pay-per-session, flat rate, asymmetric bandwidth, and others. The higher bandwidth of UMTS also promises new services such as video conferencing, UMTS promises to realize the virtual home environment, that is VHE, in which a roaming user can have the same services to which the user is accustomed when at home or in the office, through a combination of transparent terrestrial and satellite connections. Trials of UMTS technology using advanced mobile phone or computing device prototypes are currently being conducted by Nortel Networks and BT, that is British Telecommunications. LTE 4G services in mobile communication. In this video, we are going to see about LTE 4G services in mobile communication. 3GPP engineers named the technology long-term evolution because it represents the next step, 4G, in a progression from GSM, a 2G standard, to UMTS, the 3G technologies based upon GSM. LTE provides significantly increased peak data rates with a potential for 100 Mbps downstream and 30 Mbps upstream, reduced latency, scalable bandwidth capacity, and backwards compatibility with existing GSM and UMTS technology. Future developments too could yield peak throughput on the order of 300 Mbps. The upper layer of LTE are based upon TCP or IP, which will likely result in an all-IP network similar to the current state of wired communications. LTE will support mixed data, voice, video, and messaging traffic. LTE uses OFDM, that is orthogonal frequency division multiplexing, and in later releases MIMO, that is multiple input multiple output antenna technology, similar to that used in the IEEE 802.11n wireless local area network, that is WLAN standard. The higher signal to noise ratio, that is SNR, at the receiver enabled by MIMO along with OFDM provides improved coverage and throughput, especially in dense urban areas. LTE is scheduled to be launched commercially in 2010 by Verizon Wireless, and AT&T Wireless, T-Mobile and Alltel have also announced plans to roll out 4G capabilities based on LTE. These networks will compete with Clearwire's WiMAX for both enterprise and consumer broadband wireless customers. Nortel and other infrastructure vendors are focusing significant research and development efforts on the creation of LTE base stations to meet the expected demand. When implemented, LTE has the potential to bring pervasive computing to a global audience with a wireless experience for mobile users everywhere. Wireless security threats. In this video, we are going to see about wireless security threats. Wired and wireless LANs share some common security risks: physical security, inside attacks, unauthorized access, and caves dropping. A study published by the Wi-Fi Alliance in October 2001 found that security has been and remains the overriding concern regarding wireless networking deployment, that is WECA 2001b, among 72% of the wireless intenders and 50% of wireless adopters. Types of security threats. A taxonomy of security threats is depicted. These attacks can come from internal or external sources. Passive attacks. An unauthorized party gains access to a network and does not modify the resources on the network. Types of passive attack include eavesdropping. An attacker simply monitors message content. For example, an unauthorized person drives through the city and listens to various WLAN transmissions within different organizations, that is, war driving. Traffic analysis. An attacker monitors the traffic for communication pattern analysis. The statistics collected can be used to perform a dictionary attack. Active attacks. An unauthorized party gains access to a network and modifies the resources on the network. An attacker must first spoof either the MAC address or Internet Protocol address of a user or device to gain network access and then change the content of the network resources. Types of attack include masquerading. An attacker impersonates an authorized user and thereby gains certain unauthorized privileges. Masquerading includes the use of spoofing, rogue APs, and redirection attacks. An attacker can fool users to log into the rogue AP by placing a rogue AP in the same areas as a valid AP, sending the same service set identifier but with a stronger signal than the valid AP. Replay. An attacker monitors the traffic that is passive attack and then retransmits the message as the legitimate user. Message modification. An attacker alters the legitimate message by deleting, adding, changing, or recording it. Furthermore, an attacker may wish to alter the configuration of a device using, for example, Simple Network Management Protocol, that is SNMP, to configure APs. Denial of service, that is DOS. An attacker prevents or renders the normal use of management of network system useless by issuing malicious commands or injecting a large amount of traffic that fills up the radio frequency. This type of attack can be further extended to distributed DOS, that is DDoS attacks. Authenticity. In this video, we are going to see about authenticity. Authenticity. Authenticity is assurance that a message, transaction, or other exchange of information is from the source it claims to be from. Authenticity involves proof of identity. We can verify authenticity through authentication. The process of authentication usually involves more than one proof of identity. That is, although one may be sufficient. The proof might be something a user knows, like a password, or a user might prove their identity with something they have, like a keycard. Modern biometric systems can also provide proof based on something a user is. Biometric authentication methods include things like fingerprint scans, hand geometry scans, or retinal scans. Ensuring authenticity. For user interaction with systems, programs, and each other, authentication is critical. User ID and password input is the most prevalent method of authentication. It also seems to present the most problems. Passwords can be stolen or forgotten. Cracking passwords can be simple for hackers if the passwords aren't long enough or not complex enough. Remembering dozens of passwords for dozens of applications can be frustrating for home users and business users alike. Single sign-on SSO solutions. Two-factor or multi-factor authentication is more common in the enterprise for mission-critical applications and systems. Multi-factor authentication systems may use key cards, smart cards, or USB tokens. Public key infrastructure, that is PKI authentication, uses digital certificates issued by a central or third-party authority. Secure socket layer, that is SSL, connections to websites provide not only encryption for the session but also that is usually provide verification that the website is authentically the site it claims to be. Authorization. In this video, we are going to see about authorization. Authorization is a process of giving someone permission to do or have something. In multi-user computer systems, a system administrator defines for the system which users are allowed access to the system and what privileges of use, that is, such as access to which file directories, hours of access, amount of allocated storage space, and so forth. Assuming that someone has logged into a computer operating system or application, the system or application may want to identify what resources the user can be given during this session. Thus, authorization is sometimes seen as both a preliminary setting up of permissions by a system administrator and the actual checking of the permission values that have been set up when a user is getting access. Accountability. In this video, we are going to see about accountability. Accountability is an essential information security concept. The phrase means that every individual who works with an information system should have specific responsibility for information assurance. The tasks for which an individual is responsible are part of the overall information security plan and are readily measurable by a person who has managerial responsibility for information assurance. One example is a policy statement that all employees must avoid installing outside software on a company-owned information infrastructure. The person in charge of information security should perform periodic checks to be certain that the policy is being followed. Wireless security of 802.11b or G or N or AC in typical network. In this video, we are going to see about wireless security of 802.11b or G or N or AC in typical network. 802.11a, 802.11b, 802.11e, 802.11g, 802.11n, 802.11ac, 802.11a. An extension to 802.11 that applies to wireless LANs and provides up to 54 Mbps in the 5 GHz band. 802.11a uses an orthogonal frequency division multiplexing encoding scheme rather than FHSS or DSSS. (802.11b) An extension to 802.11 that applies to wireless LANs and provides 11 Mbps transmission with a fallback to 5.5, 2, and 1 Mbps. In the 2.4 GHz band, 802.11b uses only DSSS. 802.11b was a 1999 ratification to the original 802.11 standard, allowing wireless functionality comparable to Ethernet. (802.11e) a wireless draft standard that defines the quality of service, that is QoS, support for LANs, and is an enhancement to the 802.11a and 802.11b wireless LAN, that is WLAN specifications. (802.11e) adds QoS features and multimedia support to the existing IEEE 802.11b and IEEE 802.11a wireless standards, while maintaining full backward compatibility with these standards. (802.11g) applies to wireless LANs and is used for transmission over short distances at up to 54 Mbps in the 2.4 GHz bands. (802.11n) 802.11n builds upon previous 802.11 standards by adding multiple input, multiple output, that is MIMO. The additional transmitter and receiver antennas allow for increased data throughput through spatial multiplexing and increased range by exploiting the spatial diversity through coding schemes like Alamouti coding. The real speed would be 100 megabits per second, that is even 250 megabits per second in PHY level, and so up to 4 to 5 times faster than 802.11g. (802.11 AC) 802.11 AC builds upon previous 802.11 standards, particularly the 802.11n standard, to deliver data rates of 433 Mbps per spatial stream or 1.3 Gbps in a 3-antenna, that is 3-stream design. The 802.11 AC specification operates only in 5 GHz frequency range and features support for wider channels, that is 80 MHz and 160 MHz, and beamforming capabilities by default to help achieve its higher wireless speeds. Taxonomy of 802.11 authentication techniques. In this video, we are going to see about taxonomy of 802.11 authentication techniques. The IEEE 802.11 specification defines two means to validate wireless users attempting to gain access to a wired network: open system authentication and shared key authentication. One means shared key authentication is based on cryptography and the other is not. The open system authentication technique is not truly authentication. The access point accepts the mobile station without verifying the identifier of the station. It should be noted also that the authentication is only one way. Only the mobile station is authenticated. The mobile station must trust that it is communicating to a real access point, that is AP. With open system authentication, a client is authenticated if it simply responds with a medium access control. that is MAC address, during the two-message exchange with an access point. During the exchange, the client is not truly validated, but simply responds with the correct fields in the message exchange. Obviously, without cryptographic validation, open system authentication is highly vulnerable to attack and practically invites unauthorized access. Open system authentication is the only required form of authentication by the 802.11 specification. Shared key authentication message flow. In this video, we are going to see about shared key authentication message flow. Shared key authentication is a cryptographic technique for authentication. It is a simple challenge-response scheme based on whether a client has knowledge of a shared secret. In this scheme, as depicted conceptually in figure 6.21, a random challenge is generated by the access point and sent to the wireless client. The client, using a cryptographic key that is shared with the AP, encrypts the challenge, or nonce as it is called in security vernacular, and returns the result to the AP. The AP decrypts the result computed by the client and allows access only if the decrypted value is the same as a random challenge transmitted. The algorithm used in the cryptographic computation and for the generation of the 128-bit challenge text is the RC4 stream cipher developed by Ron Rivest of MIT. Privacy. The 802.11 standard supports privacy, that is confidentially, through the use of cryptographic techniques for the wireless interface. The WEP cryptographic technique for confidentiality also uses the RC4 symmetric key stream cipher algorithm to generate a pseudo-random data sequence. This key stream is simply added modulo 2, that is exclusive or ED, to the data to be transmitted. Through the WEP technique, data can be protected from disclosure during transmission over the wireless link. WEP is applied to all data above the 802.11 WLAN layers to protect traffic such as Transmission Control Protocol or Internet Protocol, that is TCP or IP, Internet Package Exchange, that is IPX, and Hypertext Transfer Protocol, that is HTTP. As defined in the 802.11 standard, WEP supports only a 40-bit cryptographic key size for the shared key. However, numerous vendors offer non-standard extensions of WEP that support key length from 40 bits to 104 bits. At least one vendor supports a key size of 128 bits. The 104-bit WEP key, for instance, with a 24-bit initialization vector, that is IV, becomes a 128-bit RC4 key. In general, all other things being equal, Increasing the key size increases the security of a cryptographic technique. However, it is always possible for flawed implementations or flawed design to prevent long keys from increasing security. WEP privacy using RC4 algorithm. In this video, we are going to see about WEP privacy using RC4 algorithm. Let's look at WEP mechanics in more detail. This section looks at the various aspects of WEP, including the encryption exchanges and mechanics, RC4, how an initialization vector, that is IV, is generated and handled, and finally, how keys are generated and distributed. WEP mechanisms, that is the encapsulation of data frames to attempt to provide message confidentiality and message integrity, are aimed at achieving wired characteristics of the wireless connection. In WEP, the packets are encrypted so that listeners cannot make sense of the garbled bits. This achieves the confidentiality equivalent of the wired environment. Moreover, entities are authenticated before they are allowed to join the network and get the keys to decrypt the information. In a way, this gives the equivalent of a wall jack. The encryption algorithm used by WEP is the RC4. RC4 is a symmetric algorithm, that is, it uses the same key for encryption and decryption and is a stream cipher. The key is a stream that is operated against a plain text to produce a ciphertext. RC4 has two phases, key stream generation and encryption. Key stream generation is a set of state machine and mixing operations that result in a pseudo-random stream of bits. The key setup takes a seed, which is a key as referred to outside the RC4 machine. After the state table is initialized, the values are used to generate a key stream. The fundamental encryption operation really is an XOR of the plain text with the generated key stream. RC4 is used in many products including Lotus Notes and is indicated in many specifications including the Cellular Digital Packet Data, that is CDPD specification for wireless packet data access over cellular networks. Taxonomy of security attacks. In this video, we are going to see about taxonomy of security attacks. A taxonomy of security over a mobile ad hoc network. It can be divided into two main categories, namely active and passive attacks. A passive attacker does not modify the transmitted message, while an active attacker attempts to modify or destroy the message being exchanged between two nodes. Active attackers can also insert false information and send to another node. Active attacks are more harmful than passive attacks. Ad hoc on demand distance vector, that is AODV, is the well-known reactive routing protocol for mobile ad hoc network that maintains routes only when it is required by the source node for communication. When a node wants to send a data packet to the other nodes, it initiates a route discovery process by sending a route request, that is RREQ packet. Neighboring nodes, after receiving a RREQ packet, check routes for the destination node. In case a route to the destination node is not available, they further forward RREQ packet to its neighbor node. If a route request packet reaches to the destination node, then the destination node sends a RREP packet to source node with the help of intermediate nodes. AODV routing protocol is vulnerable to several security attacks such as black hole, that is malicious node. A black hole node could advertise that it has fresh and shortest path to a destination node, thereby disgrading all packets without forwarding to a destination node. A black hole node is not comparing the destination sequence number in the RREQ packet to its destination sequence number entry currently in its routing table for a path. WEP, WPA, TKIP and AES. In this video we are going to see about WEP, WPA, TKIP and AES. WEP, Wired Equivalent Privacy. Most of the issues with wireless security have centered on the encryption or lack of data as it passes through the air. The first take at protecting this data was WEP, or Wired Equivalent Privacy. It is based on the RC4 stream cipher encryption algorithm. Originally, the WEP key length was limited to 40 bits to meet export-grade encryption, so the solution could be used and sold worldwide. One of the biggest insecurities in WEP was the use of static keys. Given the large amount of data a corporation would transmit on a WLAN, the time to obtain the shared secret used by WEP by either a brute force or dictionary attack is very short. It was not long after the introduction of WEP that people started publishing papers on how to crack WEP. Depending on the amount of traffic and the strength of the key, cracking the key could take a few minutes to a few days. WPA, that is Wi-Fi Protected Access. In 2002, while the IEEE was working on completing the 802.11i standard, they met with several members of the Wi-Fi Alliance to develop an interim solution for wireless security known as WPA, or Wi-Fi Protected Access. Several vendors such as Microsoft, Linksys, and Cisco have produced equipment or software to take advantage of WPA. WPA is a firmware upgrade that overrides WEP. It addresses the encryption weakness of WEP and adds strong user authentication, which was unavailable in WEP. The solution uses TKIP, that is Temporary Key Integrity Protocol, and has dynamic keys that change about every 10,000 packets. It also uses 802.1x for authentication. Temporal Key Integrity Protocol. TKIP is the new generation of WEP. TKIP provided dynamic encryption keys for each data packet, a message integrity check value, that is ICV, and a mechanism for periodically assigning new keys to network stations. Each of these features is intended to correct problems of WEP. TKIP uses 128-bit temporal keys that are combined with the wireless station's MAC address and a 16-octet initialized vector, that is IV, to produce a key used to encrypt the data payload of a frame using the RC4 algorithm. A temporal key is one that is used for just a certain time or a set number of packets. The TKIP temporal key is used for 10,000 packets before it is replaced with a new key. AES, that is Advanced Encryption Standard. AES, the new government-grade encryption standard, will most likely be part of the 802.11i standard or will be offered by many vendors as an add-on to encrypt wireless traffic. Unfortunately, AES requires more processing power for the encryption and decryption and will most likely require an encryption coprocessor to perform this task. This means in most cases, upgrading equipment will be the only way to use AES, as it will reside on chipsets rather than firmware. Most vendors are now working on upgrade plans for their customers, but depending on the size of a wireless deployment, there may be a significant cost to do this. The cost associated with the upgrade will probably delay AES from becoming the standard in corporate environments.